Well, thanks everybody and welcome back. You're here for the day 2 plenary. Again, I'm Morgan Varner. I'm the chair of this, and we've been through about 24 hours of this, maybe 28 if my math is correct. And if you're like me, you may be suffering Zoom fatigue. I have found 2 cures for that. One is folks that are presenting being relaxed and having a conversation, which is really refreshing because we're all, I think, prone to stand in front of the computer and be very uncomfortable. So I encourage folks to stay engaged and chill out. The other cure is going for a quick walk between sessions. I need to thank a few people who have made this session or the Congress so far really a lot better. Among those, the Joint Fire Science Program, who through their tree grant program, it's a program that is not only coordinated with the Association for Fire Ecology, but many may not know this, but the Association for Fire Ecology Education Committee actually proposed and developed that process. So a really cool thing that the association does. What the tree grants do for this Congress is they support 25 graduate students to present at this meeting, covering their registration. So a pretty amazing contribution. Another thing that the Joint Fire Science Program does for us. Along those same lines, the Jones Center at Itchaway, in their contribution, they tagged it to support students generally. And so they've supported both undergraduate and graduate students to attend and participate in the Congress. And then for those who have taken advantage of it, which is, it sounds like a lot of you have, the Spanish and Portuguese interpretation, that was provided by the U.S. Forest Service Office of International Programs. I think that what I've heard so far is what a welcome that is. It brought people who wouldn't have been involved. They also supported the registration for many Central and South American attendees, and so we really appreciate their contribution. There'll be music playing at different parts of the general sessions. You'll find music in the beginning, music at the end, and that's part of a Spotify playlist that the program committee put together. In particular, Eric Knapp and Sharon Hood, with their good musical taste. See if you can figure out the fire link to each song. I'm still working on it myself. I hope that this day and a half or whatever we've been through now has been as pleasurable for you as it has been for me. Even though we're not in person, I really appreciated getting to see old friends and getting to learn a lot about what people are doing. When we looked at the poll results that Chris first put up yesterday, I've been checking it through the day, and I found out that there are 2 people who came for the beach, and I think one of them told me they're pretty disappointed that we haven't had beach scenes, so we'll try to work on that. The rest of you are excited about learning more about fire science and ecology and management, and communicating and catching up with old friends, and I hope that that's all working out. We have today for this Wednesday plenary is 2 keynotes, and I'm really excited about it. You hopefully were able to join yesterday's keynote. That was a fantastic kickoff, and we're looking for some meat here in the middle of the Congress that hopefully will touch on the theme, this Life with Fire, Prescriptions for Resilience. And I think the multiple sessions that are going on thus far and later today and for the rest of the week will touch on these same topics. And I hope that they are like the Indigenous fire stewardship. I hope that they are, even though they're long, I hope that they're teasers for more engagement. So without any further ado, I'll introduce our first keynote of the day, and it is my great pleasure to introduce Kevin Hiers, wildland fire scientist at Tall Timbers. Kevin leads the fire science application and training program Many of you know Kevin. He is one of the very few professionals in our field that has literally a boot in management and the other in science. He, for the last 25 years, has been engaged in management and science, both as a prescribed fire manager at Eglin Air Force Base, burning the most area in the United States and perhaps North America, and then as a scientist, where he's published more than 100 papers on fire behavior, ecology, and that nexus between science and management. This last year, he's been detailed with the U.S. Geological Survey as the Deputy Wildland Fire Science Coordinator. And with that, Kevin, take it away.
All right, thank you, Morgan. Let me pull up my screen here and get this in slideshow mode. It's a real privilege to be talking to this group. Let me make sure we start at the beginning, though. As the name of the conference would suggest, we're always, when we have a conference, either in person or virtually in Florida, we're always going to be talking a lot about prescribed fire. And many of you who know me knows that it's really near and dear to my heart. It's fire we use. It's how we manage biodiversity. It's an amazing tool to manage risk. And so today it's great to be able to talk to this group after just an amazing morning and early afternoon of education and sessions, special sessions on modeling and biodiversity, et cetera, to talk to you all about something that me and a very large group of collaborators have developed as sort of a topic of mutual interest, and that's prescribed fire science. And what we're going to talk about today is really a research agenda. We'll be drawing some parallels or some comparisons with our current investment in wildfire, but I really want to emphasize how this research agenda honestly is behind the power curve and how we really need the results yesterday, although we're well underway in many areas. But before I get going, I do want to recognize that I am wildland fire scientist at Tall Timbers, but some of you know that I've been detailed to the USGS. I'm here speaking on as in the capacity of my wildland fire science position at Tall Timbers today. So congratulations to many of you who have been advocating for more prescribed fire councils, PIOs, burn bosses across the country. You finally are getting the attention that you deserve, and America finally wants more good fire. You can read just about any paper across the country, and they're clamoring for more prescribed fire to address wildfire risk. And frankly, they're willing to pay for it. So in addition to normal federal appropriations, the recently passed bipartisan infrastructure bill includes $3.3 billion for fuel treatments, with a minimum of $500 million going dedicated to prescribed fire. California has also approved an additional $512 billion in vegetative treatments, including prescribed fire. So there is a financial investment in this push for more fire. But the question is, are we ready to deliver? With the focus being on risk reduction in the wildland urban interface, we're going to be targeting prescribed fire in our fuel treatments to the most difficult places and toughest conditions possible, at least here in the United States. With the 20 million acre treatment goal in the infrastructure bill, that's a lot of interface to treat. That's a lot of risk to try to reduce. And I have to ask the question is, do burn managers, prescribed fire managers have the best tools to safely accomplish this increase in capacity? What really separates success from failure in the wildland urban interface? On the left is a successful burn conducted by the U.S. Fish and Wildlife Service in hurricane blowdown debris at Tyndall Air Force Base. On the right is an escaped prescribed fire that impacted a small community here in the panhandle of Florida. And I hope to convince you that at least if we focus our attention on prescribed fire science and the research agenda that represents, that it will actually help to make sure that we promote the successful and safe expansion of prescribed fire to address wildfire risk and mitigate any downside. As I mentioned, prescribed fire is getting increasingly complex. These photos include some of the burns and conditions that I've had the privilege to set both as burn boss and as a participant in prescribed fire across the country. but we're asking our burn bosses to step into situations that are not just complicated because of the wildland urban interface, but are novel because of the conditions of the fuel. In the center is a hurricane blowdown debris left over by Hurricane Michael, Category 5 hurricane. We've got beetle kill that have elevated fuel loads, surface fuel loads across the Western United States, and we're asking people to burn in more and more complex terrain. And so what is prescribed fire science? Well, a very large group of us got together and decided that we needed to create a research agenda focused on the needs of managers who are conducting prescribed fires across the country and internationally. Pardon me while I quote myself, but until now, there's been no organized leadership for advancing prescribed fire science. And in fact, until we published the paper in Fire Ecology, I don't know that the term itself was widely viewed as substantive or even that different from the needs of wildland fire science writ large, or wildfire science support. One of the things that really appeals to me, both as a former burn boss, prescribed fire and wildland fire program manager, as well as a current researcher, is how prescribed fire science has bubbled from the ground up. There's a groundswell of interest in more information, better tools, processes that work to efficiently and safely plan and execute, conduct, implement prescribed fires nationally. And so, whether or not we were burning at Eglin Air Force Base as part of a prescribed fire combustion atmospheric dynamics research experiment, RX Cadre back in 2011 and 2012, or Tall Timbers hosting a scoping session on what prescribed fire science might be as they invested and reinvested in its fire science portfolio back in 2015. The CERTUP, ESTCP, the Department of Defense, published a fire science strategy that I had the privilege of working with John Hall on back in 2014, focused on prescribed fire as the primary target. And then the bottom-up development of a consortium dedicated to trying to tackle some of the needs of managers, as well as hosting public and integrated research manager burn events to try to understand and refine what those research needs were. So again, what is prescribed fire science? It's a focus research effort on fire we use. Therefore, it is inherently applicable and actionable. Managers are not conducting a prescribed fire by accident. And so anything that we can do to support their needs is inherently applicable and relevant to management today. It's a science on how to control fire. It's which includes, and we'll unpack this a little bit later in more detail, but ignition patterns, the choice of day. What do we have within our span of control, or our hands to be able to ensure that fire meets an objective? It's about linking smoke transport to ignition patterns and that day of burn, those things that we do control to minimize the nuisance of conducting fuel reduction or fires for other objectives. And it's an understanding, a further understanding of low intensity, or what I think David Weiss was one of the first to term marginal fire thresholds, marginal fire regimes, thinking about fire on the edge of combustion, not the intense fires we see under the 99th percentile ERC days. It's a focus on variation as a feature, not a bug. When burn managers are handed a burn block, they're not handed a theoretical unit or a theoretical burn day. They have actual variability of the fuels, the vegetation in and around that block, as well as the variability of a burn day, winds, humidity, fuel moisture. And typically with the forecast, you get a single wind direction. But variation is a key focus of the prescribed fire science agenda that we promoted. And actually, I added this since yesterday's talk. Don Hawkins, what a great talk. Thank you very much. And I started thinking that prescribed fire science is just too limiting a term. And I know that we have prescribed fire and wildfire, but it got me thinking that really intentional fire, and in the old days of fire use, or as we think broadly about cultural burning, Native American burning, or other fires around the globe, a lot of it's not prescribed fire in the same sense that we understand it in say a federal, National Wildfire Coordinating Group standard way, but it is intentional fire to meet objectives. And there's a science foundation, I think, that will promote here that broadly could help understand the safe and effective use of fire in that intentional space. I do want to point out that intentional fire, prescribed fire, does dominate fire across the globe, not only in the continental United States, where I am currently. It's the epicenter of both the numbers and acres of fire set intentionally, and in most years dwarfs the wildfire, Western wildfire seasons in terms of acreage and extent, spatial extent. But when you think globally, most of the globe is intentionally setting fire. Large portion of that's for agriculture, but if you look at, say, sub-Saharan Africa or Southern Africa, really amazing amount of fire that is working and operating in ecosystems and has been for millennia. But our investment is typically has been on the science side to combat wildfire. When we think about wildfire versus prescribed fire, two fire construct under the heading of wildland fire, just the words themselves often are confusing. But when we look at our research funding over the last, well, Morgan Varner deserves credit for doing this, but went through the Joint Fire Science Program portfolio. And in the United States, we have funded wildfire research at a 3-to-1 ratio over prescribed fire funding. When we look at what we publish through the International Journal of Wildland Fire over a 3-to-1 ratio more papers on wildfire than prescribed fire. And in fire ecology, which has done a little bit better, but over the last 13 years, we published 1.5 times more wildfire articles than prescribed fire. And yet, prescribed fire still dominates the acres that burn. And so in the United States, how we track things really it kind of helps us understand what we consider important. And over the last 20 years, 30 years, we see wildfire acres having gone up. We track them to the acre every year, but there is no commensurate database of prescribed fire across the country. What we do know is that we had to resort through the Coalition of Prescribed Fire Councils to surveys of state foresters in order to just aggregate, get a best guesstimate, at least within the continental United States, how much we actually burn intentionally. And so over the last 10 years, that survey has documented somewhere between 8 and 10 million acres of forestry, silviculture, and agri-grazing type fire is set annually. It's a very consistent amount. It may go up and down, but again, these are very, very sort of crude measures through survey results. What we don't have a good handle on is agricultural burning. In some surveys, we've estimated 12 million acres of agricultural burning, and in others, we just gave up and get kind of a default answer of about 2.5 million acres of agricultural burning in the continental United States, which produces, a wide variation in how much we think we set intentionally here in the United States. But regardless, we have a lot of fire, a lot of prescribed fire, and it dominates the acreage across the country. So one of the things that really, I'd like to highlight is that wildfire and prescribed fire are different. They differ in terms of fire behavior, the costs and economics, rates of return, social, political, legal environments. All of these factors we'll unpack a little bit, but I'm not going to try to convince you that they're different. I will just highlight some of the opportunity space that the differences represent for us as we think about how fire science can support our prescribed fire managers as we try to increase pace and scale. And a shout out, to my social scientist friends. Y'all know that I'm not one, but I have grown. I have grown my appreciation for how much social and economic science policy is needed in the prescribed fire realm over the last 10 years. Just the appreciation for how much we need to do in this arena because of the differences between wildfire, and prescribed fire. In this social, political, and legal context, wildfire is an act of God. In many cases, if it's a natural start or we have an arson start, and that ignition can be prosecuted. But when we're setting fire, we're asking for permission. And so now suddenly, as the burn boss of record, I have the burden of intent. I intentionally set that fire. And so if something negative happened, smoke into a smoke sensitive area or heaven forbid escape, I bear that burden. And so, just the state, what is at stake, and who is sort of bearing responsibility is a vast difference in intentional fire that we set and fire we fight. Public versus private. Public lands, private lands dominate prescribed fire, and public lands, wildfire tends to dominate our attention and our acres. And that's true from east to west. Although we do tend to burn a lot of our public lands here in the Southeast quite well, and they count for most of the treatment acres in the federal agencies across the country. There are regional and cultural differences that are really important. We've debated, I've heard debated, is agricultural burning prescribed fire? Well, if it creates a culture of within a region of folks that are willing to smell smoke, nuisance smoke, or understand the role that fire may play on a landscape, it may allow you to expand off of that agricultural burning culture in order to get some of the say biodiversity or risk reduction burns permitted, done through air quality permits, et cetera. For prescribed fire, state laws dominate our the permitting, the air quality, the restrictions, and what we face in order to get an authorization to burn. And then the communities of practice are vastly different. Around prescribed fire, typically we have organized as grassroots organizations through, say, prescribed fire councils, fire learning networks. There's a culture of learning, but it has developed from the ground up across organizations, because there really isn't that top-down support for prescribed fire like we see with our interagency fire communities and investment in wildfire. We would welcome that. I mean, we need that now, especially as we try to increase that pace and scale. We tend to focus on the social science side a lot on what are the barriers to increasing prescribed fire, but I think we need to start now studying thinking beyond those barriers and studying the social science needs and economics of prescribed fire implementation. What institutions are meeting their prescribed fire goals? I worked for the Department of Defense for a number of years, and DoD is an exceptionally bold and dominant user of prescribed fire within the federal system. What's the return on investment for this infrastructure bill as we try to expand prescribed fire? Are we going to get a dollar for dollar return on risk reduction for prescribed fire investment? These are really important questions to be able to answer, and they're going to require the econometrics and the social scientists and the policymakers to sort of unpack with us. Morgan Varner led a recent paper to look at how policies balance the potential cost to prescribed fire escape versus the public good of risk reduction. In a state like Florida, we have gross negligence for prescribed burners that follow the rules and are certified. That gives a lot of protection in the event of an accident, but then we also need to make sure that we protect the public too from the potential for escape. And so the promotion of a catastrophe fund was the topic of that paper. And really, this pairing of options to make sure that we cover both the risk and the reward is something that as policymakers, everybody's wrestling with right now. And what happens if something goes wrong? In the social science arena, what defines a resilient community? What defines resilient institutions? When we think about the last major prescribed fire escape that everybody knows about, the Serra Grande fire in Los Alamos, it nearly killed the culture on the Via Caldera of prescribed burning that had dominated and been quite successful there because of one mistake. How do we define resilience? How do we create resilience moving forward? Prescribed fire and wildfire behavior do differ quite a bit. Not necessarily the physics of the actual combustion processes; those are pretty much physical laws. But when we think about this, ignition is used for desired fire behavior to meet desired fire effects when we're setting fire intentionally. Whereas wildfire, we're sort of stuck with the conditions under which it ignited and is currently burning, and we're trying to leverage whatever we're given that day as a fire crew to do to accomplish suppression objectives. But in prescribed fire, fire line interactions dominate. Every time we go out, we choose an ignition pattern, maybe strip head fire if we want it to burn a little hotter, maybe dot pattern and grid ignition patterns if we want to cool it down. Intuitively, prescribed fire managers understand and have learned fire line interactions, but the science of how fire lines interact and what that means in order to control fire and meet objectives is an area of needed investment. Mentioned marginal fire already. Thinking about thresholds of combustion on the cooler end are really, really important. What can you accomplish on a given day? How do we use diurnal processes of heating and cooling, atmospheric stability, things that might moderate or ameliorate fire conditions that don't meet objectives, but can be used in order to accomplish. And then rate of spread, which has dominated our understanding and of fire behavior modeling for wildfires, and critically so, because we're worried about how far can it go, firefighter safety. Now we need to be thinking about, fire line intensity for specific objectives, surface fire regimes, and the heterogeneity of that intensity and energy release rate, and we'll unpack that a little further as well. So let's dive into prescribed fire behavior very briefly. We're going to go through some new models of fire-induced flow and a couple of fire atmospheric feedbacks. We had an entire special session on this that just ended. I feel like I'm on a Zoom marathon, but just an amazing array of new tools that are being developed for this purpose. We're going to talk about ignition pattern, prescription windows, and then variation as a fundamental property of prescribed fire needs and research moving forward. But I do want to shout out, and I didn't have a great place to put this, but concurrent to AFE is the Department of Defense CERTUP Symposium. And in 2014, based on the science strategy, the Department of Defense invested nearly $23 million in largely prescribed fire-related research. Many of the PIs are here at this conference. Susan Pritchard's leading a 3D Fuels project, Andy Hudak, Russ Parsons, Chad Hoffman. A lot of them are also reporting back to CERTUP on progress of this, but the Department of Defense burns more per acre owned than any other federal agency. And it recognizes the critical role that prescribed fire has always played in reducing risk and meeting its military mission objectives. And those include at-risk species, fire-dependent species, and the public around them. And so, we have a kickstart on some of this research agenda largely through the Department of Defense. But to jump back into a couple fire atmospheric feedbacks, there's some really big differences between wildfire and prescribed fire. Rod Lynn presented a little bit on this morning, but on the bottom right, you see a wildfire burning. Wildfire ignitions tend to start and move progressively with the wind, removing vegetation through consumption along the way. That removal of vegetation progressively with the wind reduces drag forces behind, allows more efficient wedging of wind from aloft to get behind and increase and efficiently move that fire and spread it along in a direction. Most prescribed fires are done the exact opposite way. We start with a baseline, so backing fire along a black line operation. We might have progressive ignition that slowly move up into the wind, upwind. Even if we're setting head fire, might have 4 or 5 people walking across, and then they come back and do it again. We're moving from downwind to upwind. We're keeping the vegetative drag of the upwind vegetation, unburned fuel, as a governor screw on the fire behavior. And so even though the physics are the same, the mechanisms and the dominant forces are not. And so that's a critical difference that we really need to focus in on for prescribed fire science moving forward, and the models that we try to develop for managers to plan. To build on this just briefly, and I really do want to highlight, there are a variety of tools, and that special session, Ruddy Mel and Rod Lynn and many others really did go through the variety of new couple fire atmospheric behavior modeling tools that are coming out from high fidelity, computational fluid dynamics models like FireTech on the left here shown. But these tools are going to allow us to really focus in on what prescribed fire managers care about. They care, do I have the risk of escape? Fire effects, am I accomplishing my objectives? Do I kill the things I want to kill? Do I not kill the things that I don't want to kill? And then smoke management. And the thing that we highlighted this morning at that special session is that smoke management is an inherently integrated piece of ignition and combustion in these coupled models. And that's really important so that the things we control, choice of day, ignition pattern, cascade into what smoke outcomes are. And here on the right, you can see more aggressive ignition pattern with the lofting, a little less aggressive ignition pattern here with the dot and grid pattern that doesn't quite burn out as fast and loft smoke as high. Of course, the firefighter safety, rates of spread, those objectives will always be what drives our fire behavior modeling for incidents. But increasingly, we do have sort of mini prescribed fire operations within large fires. How do we burn this out without, say, blowing through a watershed and reducing or affecting the hydrology post-fire when we're doing a burnout operation? And so there are going to be some cross-pollination of ideas and models and tools and techniques. Just very quickly, let's dive into this difference in ignition pattern. We are working on this, and a couple of us, including Matt Jolly and Joe O'Brien, and I realized we really don't have the precise language to describe ignition pattern. When we typically plan for it in a burn plan, we say, line, dot, dash pattern, might have five ATVs, or if you still could use those, if you're in the federal service, might be 5 igniters walking across a unit, or a drone versus a helicopter. All of those come with different rates of fire line production, and all of that matters as to how fast fires burn together, coalesce, and lost smoke. And so we really need to be thinking about, what is ignition pattern? Do we have the right terms, language, and do we teach how it controls both fire behavior, but then also inherently those emissions that we're producing and trying to manage? In fact, here in the East, we're more emissions managers than fire behavior managers. It's just the dominant source of concern for us setting fire. And as we move into the urban interface, that will, in the West as well, that's going to also be a dominant concern, both in terms of permitting, but also, nuisance impacts. Just a quick highlight that in order to run and think about fire and variation, fire behavior models that include this kind of variation, we need to reimagine what drives fire and how we think about it. We published a paper in 2009 called The Ecology of Fuels, and we really have, for the first time, Russ Parsons presented Fast Fuels, which is a new tool that takes three-dimensional forests and turns them into 1-meter cells that feed these next generation fire behavior models. We're able to characterize variability through the 3D Fuels project that Susan Pritchard's leading. Variation in vegetation is now capable of being represented, and we can start exploring what aspects of that variation is really critical for for us moving forward. We need to also think about how that vegetation recovers. How long since fire do things have? Do they come through and allow us to really plan ahead and start managing fire regimes, not fire events? These three-dimensional inputs is a topic that Andy Hudak has taken the lead on, both with this past project and one of the current startup projects. And then linking that fire behavior, ignition pattern of fire behavior in management relevant ways, whether it's through new technology. And this is a model called QuickFire that's taking a drone ignition that happened on the Hitch-T experimental forest, and in retrospect, modeling that pattern with different fuel moisture scenarios to see if the outcome they got would have been different had they burned it under different conditions. The term marginal fire is something that we have to unpack. We have to be thinking about backing fire and flanking fire, surface fire regimes that are dominated by heterogeneous moisture content, not a single value for fine dead fuel or fine live or for live fuel. And being able to predict desired effects is going to require us thinking about these things in very different ways. Prescribed fire weather is also different. Days since rain, we know, is important. We don't have a single model that allows us to understand why it is. And yet prescribed fire and wildfire acres tend to burn under dramatically different time since rain events as you plot those data. And deep manager understanding of local conditions is really important for prescribed fire conditions and planning and implementation. And those micrometeorological effects are a topic of active research and need a lot more investment. Understanding the burn prescription window itself has to be reimagined. Every time we have an accident or something goes wrong, we just assume those conditions were wrong and we squeeze them further and further down. And so we reduce our prescription window every time there's an accident, rather than really investigating, hey, what was the variation that included or that led to a negative outcome? We need to be thinking about how we truly identify safe burning conditions, match those with ignition patterns, and then variation in potential wind fields, and assess through ensembles and these new modeling tools how safe was that burn prescription window. Now, at a course scale, we started to think about the window in broad terms. Like, here in Florida and Georgia, we took 250, roughly 250,000 permits, and we said, when do people burn? And we identified the safe days that people are currently burning under 98 percentile conditions. And then Adam Tarando, John Kupfer modeled those forward to think about, how does prescribed fire opportunity change with climate change? This is another important part of climate adaptation, because as we know, prescribed fire is going to be one of the most critical adaptation tools we have moving forward. And lastly, mechanistic fire effects. Fire effects are the primary objective of prescribed fire. We want to create desired effects and minimize negative ones. And certainly planned units have edge effects. We think about heterogeneity at multiple scales, large and small, and that variation matters to ecological outcomes, species, habitat, as well as risk reduction. I'll just leave you with this, that the dose relationships is Ruddy Mill, his WFDS model, looking at fire moving around the backside of a tree, this wake eddy effect, thinking about the dose of energy and how energy drives ecological outcomes. A variation in energy leads to predictable fire effects under novel conditions, is something that Joe O'Brien's emphasized out of the Athens Fire Lab. And really thinking about dose and mechanisms behind how our desired fire behavior creates outcomes is very important. Morgan, I know we're running up on time. I've got a couple of more slides. I just want to emphasize that business as usual won't work. We have to have an investment, but we got to have an investment of creative new ideas. And the only way to get there is a diverse community, and inviting a diverse community to participate. To change the game, we need these new perspectives, and we have to increase the comfort for non-traditional disciplines to step in on a fire line. We cannot have qualifications be a barrier to getting those, the non-traditional disciplines, be it social science, economics, in some cases, fluid dynamicists and modelers onto the fire to work with managers to understand the problem. And we have really dedicated through a program called the Prescribed Fire Science Consortium to bringing in young scientists and people together with managers on burn events, so that we can have a robust conversation about what the needs are. Of course, we recognize that prescribed fire science and wildfire science are not two wholly separate things, and there is quite a bit of overlap and opportunity space that the agenda that I just laid out for you can help address, be it burnout operations on a wildfire, trying to decide which wildfire to let burn to meet ecological objectives. And so we understand that there will be flow of ideas and opportunities both ways, but this is an investment we need to make now. It's going to require in-reach and outreach. It is inherently manager-driven, and we need to make sure that the managers are involved in both structuring research, conducting it, and then getting products from the technological advances that are made. Globally, we know we need more fire, and there's only two ways to get it. And that's to set it or let it burn. Trial and error, however, the way I learned to set fire is no longer acceptable. Society's not tolerant of the error part of that equation. And so we need a robust fire science management partnership to actively create these applications to increase the pace and scale moving forward. And then we got to recognize that prescribed fire science has to seek to understand fire cultures, be inclusive, add diversity to our ranks, and support regional innovations while improving the modeling tools to manage our collective risk. With that, I just want to recognize all the large collaborators. If your name's not there, I apologize. Trying to pull this together. There's just a tremendous amount of people that are participating in these activities, trying to move this research agenda forward. And with that, I'll be happy to take any questions.
That was great, Kevin. Thank you. We have a couple questions. The first one, Kevin, what do you see is the biggest barrier to conducting more prescribed fires, and how do we start to overcome that to get more area treated annually?
I think that recognition has been historically one of the bigger barriers. And that's why I was really excited to see, the headlines. I mean, you can't type in a Google search without seeing now support for more good fire. Now I see the biggest barrier is a rush to burn in these hard places. And I worry, are we resilient to inevitable problems? when we bite off the toughest places, fire becomes, as James from one of my fire mentors used to say, Kevin, at Eglin, I can't afford to burn any less than 100,000 acres. It's just too hard. It's too hard to burn less, right? When you start to try to go from small to more, you're picking off, units that haven't been burned. The fuel's not been reduced. You got smoldering conditions. You've got a lot of complexity. You haven't mitigated that complexity before, so you're stuck with uncertainty. So I worry that one escape and we have a Cerro Grande type response, which is a total pullback. And if we can start anticipating now, these are going to be problems and there will be mistakes. We want to be robust and resilient to that. We want to minimize them. We want to put the technology in the hands of managers who are not doing routine burns per se. I mean, I don't need help burning my property in South Georgia, but when you step into the, complex terrain, complex contexts, we need that technology now.
That's great. Well, I feel like this topic and your mixture of experience is it's a nice dose of reality in this exciting period. I love the way you had the headlines, because it is sort of exchange a couple nouns or verbs, but the same sort of thing continues to come. And now we face that challenge. Here's another question. How does a backburn during a wildfire event relate to prescribed fires or intentional fires? This is a tool used extensively in our area by fire agencies.
Absolutely. That's one of those areas of definitive overlap, right? For the first time, we were working with one of the Southern area teams to sort of model out, and we weren't doing this fast enough for operational use, but to think about how can we burn out or a backburn versus, a true burnout in order to meet objectives. If we have an opportunity to slow down the fire spread, but we don't want to blitz a watershed that may be critical habitat for trout or, or for municipal water supply, how do we accomplish those objectives and balance the need to reduce the fuel, stop the fire, but also preserve, say the infrastructure needed, provided by national infrastructure provided by a watershed? I think that's one of those areas of blended overlap that these new tools and new approaches, definitely could help address. And I don't want to make too much of the differences, but more or less the opportunity space for the investment going forward.
Yeah, great. All right, we have time for one more. And this is from Alina Kanzler. She asked, is there potential for federal support for standardizing geospatial data records on prescribed fire across all types of land ownership and management, as you discussed?
Amen.
If the data were available in a standardized format, there are many additional questions we could address.
Yep. Yeah, there are some wonderful opportunities. Wonderful efforts underway. Casey Teskey has been working with Todd Hawbaker, Joe Noble on a burned area product derivative that looks at kind of time since fire. They've got some ideas for how to improve both the accuracy and spatial resolution of that. I think that we definitively need that database. Without a doubt, it would help update land fire. It would help, help us monitor fuel treatment effectiveness. I mean, you can't, at a landscape scale, if you don't know when and what burns and how often, you can't make good decisions. I mean, that is a huge barrier.
Nice.
Thanks for bringing that up too. That's fantastic.
Yeah. Well, thank you, Kevin, and really appreciate it. And I know there are others popping up now. Please chat with Kevin in the Hova app, or as Kevin would pronounce, the Hova app. And thank you, Kevin, again. Okay, well, this is fun. It's also my pleasure to introduce our next keynote. This is Dr. Sally Archibald, who's a professor at the University of the Witwatersrand, which I just messed up the pronunciation, even though I practiced it for an hour this morning, where she works on the understanding the dynamics of savanna ecosystems in the context of global change. Sally's work integrates field ecological data, remote sensing, modeling, and biogeochemistry. She's currently involved in collaborative research projects on grass functional traits, intercontinental savanna comparisons, and the origins of wet-dry seasonality in Africa. Sally's received lots of accolades. From my own experience, if I'm looking for a paper on savanna and fire ecology and Sally's name is associated, I know it's going to be really great. So we're really excited to welcome Sally. And Sally, take it away.
Great. Thank you so much, Morgan. It's really great to be here. Let me just get my screen shared. I want to thank you for inviting me to talk. It's been such fun to engage with you guys and hear some of the really exciting talks over the last few days. And it's a wonderful opportunity to kind of bring together some ideas and think about this topic that I chose to talk about, which is bridging theory and application. I think, as Morgan mentioned in his introductory talk yesterday, fire science is interdisciplinary. People here in this conference range from evolutionary biologists to mathematicians to policymakers and conservationists. And I know that I, as a sort of intellectual butterfly, have hopped between these different disciplines, and I've been stimulated so much by the interactions that I have with different people working with different disciplinary backgrounds. And so the approaches are really varied. And there is some communication between these different disciplines, but I think more would really be good. So I thought today I would try to just give 3 examples where I have found that conversations and insights between different disciplines have proved helpful. So we're linking more theoretical approaches to more applied approaches have gained us some ground when it comes to fire science. I'm going to be starting by talking about threshold behavior. Many people who work with fire spend a lot of time working on how to put fires out. But I suppose I, throughout my time working with fire, have been really more interested in why fires go out when we don't put them out. These 2 fires that you see in the slide, both lit within a few hours of each other in the same landscape on the same day. One of them went out after a few minutes and the other one burned for days. And I just find that really fascinating. And I think, thank you very much, Kevin, for introducing this concept of marginal fire. I think we really need to think about it. When it comes to threshold behavior in fire, there's plenty of examples that fire shows threshold behavior. The classic one would be burn probability along different oxygen concentrations, where you get this massive increase close to about 20% oxygen from a non-flammable to a flammable system. But everywhere you look in the literature, when you're trying to understand fire, you find these non-linear relationships with moisture content, with terpene content in leaves, relative humidity. And Gareth Hempson and I, when we were looking at the area burned across Africa in association with grazer density, also found these sort of non-linear threshold responses of fire. So to a physicist, this wouldn't be surprising at all, because physicists for many decades have realized that fire is an example of an infection process. So percolation theory is used, and I suppose percolation theory would be thinking around interacting components and how connected they are. And you can think about it in terms of water moving through a porous substance. But really the question is, how connected are these systems? And can you find an infinite cluster which allows a disturbance to move from one side to the other? But the key insights from understanding percolation theory and the mathematics is that infection processes show threshold behavior. Now, epidemics are another example of an infection process. And I think for all of us who have been living through a pandemic, this graph will not be unknown to us. We will all have seen these sorts of graphs where you have beginning of an epidemic, you have a lot of susceptible people, you have very few infected people, but the infected people infect other people, and you end up with this saturating curve where you have an increase in the number of recovered people and a decrease in the number of susceptible people, and that's the point where the epidemic goes over the turning point. But one could just as easily use exactly the same graph to model an individual fire spreading. You just have to turn susceptible people into flammable patches, infected people into burning patches, and recovered people into burnt patches. So we know that disease spread depends on the probability of infection, as well as the number of individual interactions within the population, which is why we're given this guidance that we must wash our hands to reduce the probability of infection, but we must also stay at home to reduce the number of individual interactions. So these are two different drivers that both result in this parameter, which tells you how quickly the epidemic will spread. And similarly with fire spread depends on fire intensity, which you could think of as spread probability, the chances that a burning cell will ignite the next cell, as well as fuel connectivity, which tells you how connected the susceptible or unburned cells are. So it's quite useful when you're trying to generalize understanding about threshold dynamics to think of these two different drivers. Let's start thinking about the fuel connectivity driver. And this is where the threshold comes in, is that when you start to decrease the percentage of a landscape that is flammable from 90% to 80%, 70%, all the way down, you reach a threshold where before, if you lit the fire, it would move through the landscape. And after this threshold, if you light a fire, it's never going to get from, it'll get bigger, it might vary in size, but it's never going to burn through the entire landscape. And depending how the mathematicians set up their landscapes, the percolation threshold is around 59%. But as Kevin was talking about in many of the talks today, that's not the only driver of percolation in a fire system. That defines how connected the landscape is, but then you've also got how flammable the landscape is, so the spread probability. And what we find is if you change the spread probability, then the percentage of the landscape that needs to be connected in order for fire to burn changes as well. So these two dry factors play off against each other. If you just draw the results of some simulation models where you spread fire through landscapes that vary in terms of how connected they are, what the proportion flammable is, but then they also vary in terms of the spread probability. So if the spread probability is 1, if every burning cell is going to ignite the next cell, then you need about 60% of the landscape to be flammable before the fire will spread. However, once the spread probability declines, you need more and more of the landscape to be flammable before the fire will spread. So for less intense fires, more of the landscape needs to be flammable for the fire to spread. So this is all very exciting, and I have spent many years of my life pondering these sorts of graphs, but only recently did we have an opportunity to test whether these sorts of theoretical percolation thresholds really do emerge in real landscapes. So together with Annabelle Cardoza and Carla Staver, we have been lighting fires in landscapes across the globe and recording whether they burned or not, as well as fuel connectivity. So in each of these graphs, you'll have many, many fires lit in the same landscape under the same conditions. The only thing that varied is fuel connectivity. So we use this to define these thresholds. And the first thing you'll notice is that, yes, there's definitely threshold behavior in real fires. Real fires, when the landscapes are connected, they will burn. And then very suddenly you'll get to a point where the landscapes become disconnected and they stop burning. The dashed graph here represents the expected threshold behavior when the spread probability is 1. And you will see that in all of these real landscapes in South Africa and in Cedar Creek in the USA, the actual lambda is estimated to be less than 1. So the actual lambdas are estimated to be around between 0.7 and 0.8 in these landscapes. Except in the one place where we lit these fires, in Lope National Park in Gabon, where they get sort of 3 meters of rain and a lot of grass. And so the expected thresholds were fitted to the expected line of a spread probability of 1. So definitely we find these threshold behavior in real fires, in real grassy ecosystems, which is pretty exciting. Now it's quite easy for us to conceptualize landscape connectivity, and we use it a lot when trying to manage fires. But what exactly does spread probability mean to a fire practitioner or someone who's setting fires? So the other thing we did was to take even more fires. We took a database of around over 1,000 fires in the Kruger National Park and calculated the infection probability for each of these fires in each of these landscapes, and then correlated that with weather conditions and fire behavior. So you'll see that what we're calling infection probability, which is a theoretical parameter in a very simple percolation model, is equivalent to the mean rate of spread. It's like a nice linear relationship. And as wonderfully as, I mean, it's not often that these things work out so beautifully, but as you approach a mean rate of spread of 0, you end up with an infection probability of 0.6, which is where the mathematicians reckon fire should switch off. So in grassy systems, we find that the fires that burn through these systems follow this theory around percolation theory really beautifully. This is one more test of this. If we try to look at graphs of infection probability versus fuel connectivity, I've already said that these two parameters play off against each other. So if you ever have really connected fuel, then the infection probability can be lower and you'll still have fires burning. So these orange areas are where fires are expected to burn. Once you have a low fuel connectivity, then you need a really high infection probability before the fires will burn. These were the expected results. And this is what we observed in these marginal or threshold fires that we observed in the Kruger Park. We found exactly the same relationship and the same trade-off between infection probability and fuel connectivity. So this has been really fun. We've spent the last few years showing that our theoretical, very simple two-parameter model works in real landscapes with real fires. But I also said I was going to be linking theory to applications. So what are the implications for management? Well, actually, managers have really already been on top of these ideas for many decades. Lully back in 2004 wrote a paper talking around how you could use percolation models in risk reduction. Basically, leverage is this idea that if you burn early in the season to reduce the fuel connectivity, then even when infection probability increases later in the season, you won't get dangerous wildfires. But there are some instances where management hasn't really embraced this concept of threshold behavior. So I'm going to give you an example of the early season burning program in the Kruger National Park. In the Kruger Park has a very proactive and dynamic fire set of fire practitioners and fire research, and they follow adaptive management. So over the time they've been putting in prescribed burns, which is over 70 years now. There have been various phases of trying out different ways of applying fire. I'm just going to compare two of them. This one was the lightning management period, where for a period of about 10 years, they tried to put out all man-made fires or human-made fires in the Kruger National Park. And as you can see, they failed dismally, because even though they only put in management burns around infrastructure, and they put out all the human fires they could, but still the majority of the park burned in human-caused fires. So they're learning from that experience and learning from the literature and the new ideas that were coming out in the 1990s around patch mosaic burning. They implemented a patch mosaic burning management plan, where managers in each section of the park were told to burn a certain proportion of the park every month of the year. And that proportion was set by the biomass in their landscape. And you can see they did manage to put in a whole lot of early season burns, prescribed burns. But what managers were told to do was the sort of red line here. They were given a certain proportion of the park they needed to burn every month. You can think of spread probability as ranging from early in the dry season with a low spread probability to late in the dry season with a high spread probability. So they were told to put in a certain proportion every month in a linear manner, but the predicted fire sizes that you would get follow this threshold or nonlinear behavior. So after a few years of trying this out, we had some very frustrated managers in some very frustrated meetings telling the scientists that they were asking them to burn during times of year when fires were just not going to burn, and it was impossible. So this is an example where if the scientists who were setting these fire objectives had had a little bit more thought around the nonlinear responses in these systems and around how hard it is to put fires in when the spread probability is below 0.6 in the early dry season, it would have saved a lot of frustration from the field rangers. So let's think about modeling now. I've just attended a really wonderful modeling session in this workshop. And if you're talking about really detailed models, then most of them already have. If you're talking about models that sort of are modeling the fire front, then most of them already intrinsically have these sorts of percolation and threshold dynamics included. But once you scale up to slightly larger scales, and this was mentioned by some of the speakers earlier this morning, then the percolation process isn't explicitly modeled in your fire models, especially in global scale fire models. So do these global scale fire models need to incorporate threshold dynamics, nonlinear relationships, and percolation theory? Some colleagues of mine who know my obsession with percolation theory tell me that it really is not very meaningful to them. And here's some data demonstrating that in the same savanna that I just showed those really nonlinear responses to individual fires, if you just accumulate rainfall over the previous 2 years, you can get a pretty good estimate of burned area. And so for people working at bigger scales, in this context, perhaps there's no real motivation to engage with trying to incorporate these nonlinear dynamics. However, that being said, many global scale fire models do incorporate threshold behavior and do incorporate nonlinear dynamics. And I think when one's assessing models, it's really good to ask and look into the details and say at what point and in what drivers are you having these nonlinear responses, because it can really help to understand the value of the model. In particular, if you're trying to model area burned, then it appears that in savannas you perhaps don't need to think about percolation thresholds. But there's one other aspect of percolation thresholds to think about. Because percolation thresholds result in power law distributions, which means that extreme events are more likely than expected. And it also means that mean values are not always meaningful. So a normal distribution looks like this, and fat-tailed distribution or power law distribution has more extreme events. And there's been some wonderful papers published recently showing that almost all fires globally show these power law distributions. In fact, if you look at a map of fire size observed from satellites, you'll see a big range of fire sizes globally. However, unfortunately, our global models at the moment are not able to capture these large fire events. While they capture the burned area really accurately, and we get good estimates of area burned and good estimates of fire emissions, we aren't capable. There are no global fire models that are capable of simulating extremely large fires and predicting extremely large fires. So I would argue that percolation theory is necessary if we want to quantify extreme fire events, particularly predicting them into the future. But this doesn't always require that we have to simulate individual fires. And that's where we need to chat to the epidemiologists and the physicists, because they've been doing some detailed thinking around how to capture these sorts of emergent responses while still incorporating the important theory around nonlinearities. So that was my first example of how theory could link with management and modeling and prediction. My second one is to think about energetic constraints on fire. Now, we know that fire is a physical process, even though sometimes I use the concept of fire regimes evolving. Fire regimes can't evolve. Fire is a physical process, but fire is burning the product of biological processes. So we really do need to incorporate biology and energetic constraints into our predictions and our management. And we had a wonderful NESCENT workshop with a wonderful range of colleagues across the world where we tried to summarize these sorts of ideas, and we ended up publishing a paper that looked and tried to describe the biological and the geophysical feedbacks with fire in the Earth system, and to really demonstrate, especially to people who aren't biologists and aren't ecologists and don't necessarily think about fuels the way that biologists do, how important it is to understand plant traits and evolutionary processes if you want to understand fire regimes. In that paper, we did a bit of a literature search, and we showed that, especially at a global scale, research on Earth system feedbacks is pretty climate-centric. If you look at all the papers published on climate, fire, vegetation feedbacks, while there was a lot of overlap in papers that looked at all three components, there was a majority of papers that only looked at climate fire feedbacks without ever considering vegetation at all. Now, I have to say that attending this conference for 3 days restores my faith in the fact that there are some wonderful fire scientists thinking about this side of the feedbacks. But that doesn't mean that it always comes out in the most highly cited papers, and it doesn't mean it filters into the other disciplines who work on fire who aren't ecologists or biologists. So here are some lovely examples where, unless you understand the vegetation, you would not be able to predict the fire regimes. The first example was described to me by my colleagues because I have never been to the boreal forests. But it's a wonderful example where actually, according to the build-up index and various other measures of climate, Eurasia and Northern America have very similar climates, and yet they have very different fire regimes. Basically, as far as I understand, because Eurasian fires are dominated by larches that are deciduous. So it's all about the traits, and the traits can drive the fire regimes. And then another example of a place that I have been to, where there's a different situation, where actually you have two environments with very different climates that end up having quite similar fire regimes, are pine savannas in the USA and eucalypt savannas or any other tropical savannas. And I must say, when I first visited Bill Hoffman in the USA and discovered that there was no seasonality of rainfall in the pine savannas in Virginia and North Carolina, I was flabbergasted, because we tend to think of seasonality as being an essential for the types of tropical fire regimes that we see. But here we have an ecosystem which has no seasonality in rainfall and still burns with grassy fuels the same way our tropical savannas do. And it's all because of the traits. So here are some examples where thinking about vegetation is really important. But I'd like to think a little bit about other examples when thinking about vegetation and energetic constraints are important. This graph is plotting global data on fire return time against the fire radiative power measured by satellites. And the most obvious pattern in this graph is that there's this strong constraint on the maximum fire intensity that depends on the fire return time. If you have really frequent fires, there's a limit to how intense those fires can be. And this is quite easy to understand, because basically between fires, vegetation needs to regrow. So this constraint between fire radiative power and fire return time is controlled by regrowth rates, which means it's controlled by physics and biology. So what I take away from looking at this graph is that if we end up with more frequent fires, that will result in less energy released per fire, because there'll be the regrowth rates, the amount of biomass each time it burns will be less. But that's not the general perception that I get in many of the literature that I read, where you get these statements that the warming climate is causing an ongoing increase in the frequency and the intensity of fires. So I'm fairly puzzled by some of the papers that I'm reading around future fire regimes, because I always have this graph in mind when I'm thinking around changes in fire frequency. And changes in fire frequency for me always result in changes in fire intensity. So I think we should be asking our questions, like, we know that currently this is the constraint on global fire, but will the future have the same constraints as in the past? Plants that accumulate fuels faster can definitely relieve these constraints. So if you have plants that regrow more quickly, like invasive species, or plants with epicormic resprouting, or any new plant innovation, then we could relieve this constraint and move into this currently unoccupied fire space. But it's not clear to me how climate change is going to relieve this constraint. And I think we need to think about that more carefully, especially in our ecosystems, where we're getting shorter and shorter periods between fires and shorter times since fire. So what are the implications of this for management and modeling? Well, I think people here at in this symposium, in this conference, know a lot more about fuel management than I do, but I suppose I just wanted to highlight an interesting paper that I read in 2014, where there's a suggestion that one could promote angiosperms and deciduous trees in boreal forests to counteract the effect of higher temperatures. And this is a novel geoengineering proposal, which is slightly different from other ones, and definitely forces climate scientists to think about biology. But then the other point that I raised, which is predicting the global carbon cycle. And I think it's really important for us to find out, when does increased frequency of fire result in higher fire emissions? I would argue that only when energetic constraints would you result in higher fire emissions with increased frequency of fire, but perhaps some empirical data could correct me on that one. So to move into my final thoughts and final theoretical insight, I wanted to draw on system dynamics theory and the idea that immediate fire behavior does not predict long-term responses. Lag effects occur when a driver feeds back to a system via two different pathways, and each pathway is acting at different timescales. And in situations like this, when you have two drivers and acting at different timescales, the outcome depends on the timescale at which you're observing the process. So in fact, probably some of our discussions around fuel and fuel constraints and fire frequency probably also could be well understood in terms of lag effects. But I'd like to give you an example in terms of people and human impacts on fire, which I've studied a lot and done a lot of thinking about in Africa. Because when I was given by David Roy the first Modus fire product back in 2006 to do my PhD on, we really didn't understand a lot about fire outside of protected areas in Africa. Here is a map from 8 years of Modus fire data, showing that inside the Serengeti National Park, which is protected, we get frequent fire, but outside the park, there's hardly any fire at all. But we didn't know that before we had spatial maps that could look. So we had estimates of 75% of African savannas burning every year, because if you just extrapolate this to outside, you would get those sorts of feedbacks. And we had papers published saying that over the last century, fire in Africa has increased and increased with more increasing population size. And that made sense because we know that people in fire light a lot. People in Africa light a lot of fires, and that fire, banning fire does work. So those ideas made sense until we could see the data and think about it. But once we saw the data, then we had to think about other ways humans impact fire and think about the types of landscapes that people are living in Africa. So this is actually a photo I took just outside the Serengeti Park to the south, and you can see there's not much fuel there to burn. And this is a photograph I took just out the Serengeti Park to the north. And you can see that even though there's fuel to burn, it's a very disconnected landscape. And this is a landscape from Namibia, again, showing a really disconnected landscape. So I think what was missing in our previous thinking around fire in Africa was an understanding of human impacts on connectivity as well as ignitions. So if we just draw it into a very simple systems diagram, you have people, and people affect fires. They increase the number of ignitions. We have lots of nice data on that from Africa, showing as you increase the number of people, you increase the number of fires per square kilometer. So they increase the number of fires, and that's a very fast variable that happens immediately. And then more fires reduces the fuel, but the fuel regrows and increases the fires. So you have the system where you'd predict that more people would result in more fire. But then you also have human impacts on fuel, which are negative, as I've showed. And this is a slow variable. It doesn't happen immediately. It takes time for people to transform landscapes and to build roads and to bring in their cattle. So you find that the long-term outcome is for there to be less fire with more people. But that's only because of the slow variable that starts to build up. So you expect an immediate increase in fire when people move into an ecosystem and a long-term decrease. And that's exactly what you see when you look in the paleo record. You'll find in this wonderful paper by Nicholson back in 2000, an example where people moved into a system and started bringing in agriculture, and you had an increase in the number of fires followed by a decrease. And that fits with our theory around fast and slow drivers, so that they increased the area burned, they almost doubled it, but then they brought it down to practically nothing over time. So I think when it comes to theoretical insight 3, I think if we don't engage with lag effects, then we can result in confused messages to the public. The public in Africa has been very confused around how humans are driving fire. And if we just had some clearer ideas around the lag effects and the two different drivers, it would make much easier to communicate to the public. And it also results in unnecessary disagreements among scientists, because we don't actually have to choose one answer about how people affect fire. People do increase fire and they also decrease fire. It really just depends on the timescale that you're looking at. So to conclude, I would like to encourage everyone to talk to physicists and epidemiologists, because threshold behavior is often important to consider, but that this doesn't necessarily mean always having to simulate the behavior of individual fires. We need to be creative around how to represent these emergent responses. And then I would like to encourage climatologists and physicists to talk to biologists, because you really need to understand fire as a physical and a biological process and incorporate energetic constraints and plant evolution. And finally, we need to talk to systems thinkers, because the timescales of the feedback processes matter. I just want to end with a photograph taken by a drone as it flew over a really beautiful fire artwork that my colleague Hanneli Kutsia made in a landscape where I work near Johannesburg in South Africa. While we were lighting this fire, which was also an experiment, I had a student looking at the impacts of fire on insect populations. There was a community of people watching us light the fire and some children wandering around, and it really became a wonderful way to engage with people who live in grassy ecosystems that burn a lot, and to help them embrace and understand the fire that drives these ecosystems. Thank you very much.
That was such a cool image to leave us on. Thank you. That was really great. Annie, I'm ready when you have questions. I like that the way that you close the sort of cross-discipline thinking and collaboration is often rare. For those of us who work on how plants die, we almost never look at medical literature to look at how animals might die or how humans might die. And we know there's been orders of magnitude more research on those topics. So I really appreciate that. And I love that image. I didn't know the background. Thank you so much for that. That was great. I wonder in your own thinking and in being this morning, the way you put together those percolation ideas, and you saying you were involved in the modeling, or you were observing the modeling talks this morning. How disparate, where do you see that the sort of, we could say traditional, the modelers would fall into multiple categories, but how do you see that sort of percolation idea fitting, or how do you see those two worlds combining?
Yeah, thank you. It's been fun engaging with modelers. I've been engaging with the Global Fire Model Intercomparison Project, where they have a range of models, from empirical-based models to more process-based models, but all at big scales, where some of the beautiful dynamics that were shown in the modeling session earlier, it's just not possible to incorporate. But many, and currently I find the empirical models that are based on empirical data and empirical responses actually probably incorporate the threshold processes more explicitly, I think, than the process-based models. So many of them will have a strong nonlinear response to people, strong nonlinear response to landscaped connectivity. Whereas our process-based models at big scales, I think we're still searching for that kind of balance, which is why I think talking to epidemiologists could help. I was actually involved in trying to create a spatial model of COVID spread through South Africa last year, which ran into exactly the same problems, is how to deal with the spatial process when you want to have a really simple model. We don't have huge computational kind of facilities here in South Africa, like some of the researchers in the UK, where they can have an individual-based model where each individual is infecting each other. And so there really are some lovely theoretical ideas around how to do that at a slightly more simplified scale.
Cool. Well, great. Well, thank you. We're going to pass the baton now to Kevin to do awards. I wanted for Don, Kevin, and you for us to have an applause track, but we didn't think of doing that until right about now. So just imagine a big applause track. Kevin, it's all yours.
unmute myself and get the video going. So we're going to transition from plenary addresses to what is Morgan's favorite part of the program. It's the awards, and I will. Let me just stop this share for a second because we're gonna go through a couple of things first. But with the we've got 2 Lifetime Achievement Awards to present for 2021, and the AFE Lifetime Achievement Awards recognize individuals that have made significant contributions to fire ecology and management, and who have inspired and mentored generations of fire ecologists. These contributions, their contributions, may be in research or management, teaching, service, outreach, or a combination of these areas. And the awards are named after pioneers in the field of fire ecology and early advocates that have been presented now since 2003. The first award is going to be the Herbert Stoddard Award. And before I introduce Sam Lindblom, I want to say a little bit about Herbert Stoddard, and this is where I might try to share my screen if that's okay. Let me see if I can do that real quick. But Herbert Stoddard is really a giant figure in fire ecology. As an individual, he was somebody who didn't have but a high school education, but understood intuitively science, wildlife, fire management as an integrated discipline. And I love this quote because it really defines not only his contribution to understanding fire, but his tenacity in defending its appropriate place in our ecosystems. And Tall Timbers really is the legacy that Herbert Stoddard left behind. And so as an employee at Tall Timbers, and we're steeped in the tradition of his contribution here. But Herbert Stoddard was one time, he says in his memoir, at one time I was classed by many as an enemy of these forests because of my written and spoken insistence that the pine forest not only could be burned over frequently enough to maintain their natural vegetation and associated wildlife, but indeed should be. And I think that that's a fantastic quote. And Herbert Stoddard was also a practitioner. He is setting a control burn, a term that he may have coined, with a homemade drip torch, a design that he himself created. And if you go to one of the quail preserves down here near Thomasville, Georgia, you can see one of the initial fire lines, one of the first fire lines ever put in the 1920s. As a way of intentionally planting fire. Up until that time, it had just been open burning. But his story begins in the 1920s when, after the Forest Service had been trying to suppress fire nationwide, quail, which were abundant in South Georgia, began to decline, and a lot of wealthy industrial northern landowners that vacationed here at the end of the railroad in Thomasville, Georgia, Tallahassee, Florida, in the 20s began to be upset at that. So they hired Herbert Stoddard away from, I believe, the Natural History Museum in Chicago to come back here and understand and study why quail were declining. And he instantly recognized, having grown up in Florida, that fire was no longer being used to manage the woods, and began a lifelong study of quail that brought him to research this question of fire and its role in wildlife. What is really tremendous is that because Herbert Stoddard created, because he studied this in such a definitive way, the book, The Bobwhite Quail, Its Habits, Preservation, and Increase, is still one of the seminal works in wildlife ecology. He sort of single-handedly revolutionized wildlife management, wildlife ecology, and with his with Ed and Roy Comerick, his contemporaries here, created the field of fire ecology from scratch. And so this award really does go to the heart of what it means to be, to have a lifetime of dedication to fire management, fire research, and all of the benefits that come with good management for a variety of objectives. And so with that, I would like to introduce Sam Lindblom, who's going to then produce going to introduce the award winner. Sam's a longtime friend and colleague. who is the Director of Land Management, Fire Management at Virginia Chapter of the Nature Conservancy, and also directs the Central Appalachians Fire Learning Network. So Sam, why don't you take over and introduce our award winner for the 2021 Stoddard Lifetime Achievement Award.
All right, thank you, Kevin. Let me see if I can get video going here. That button seems to be working just yet. Can someone give me that option? Let's see.
Yep, hold on one moment.
Okay. There we go. I think I'm up. Maybe. Kevin and I had a funny conversation last night, and we thought between Morgan and Kevin and I, there was about 100% chance that we would wreck this. And so far, Morgan and Kevin have done pretty good. So I'm going to see if I can follow through and do this justice. As Kevin said, my name is Sam Lindblom. I'm the Director of Land Management and Fire Manager for the Nature Conservancy in Virginia. And today, I have the honor to recognize and present this award to my friend and mentor, Margit Bucher. The perfect intersection between science, fire management, and people, fueled by passion, curiosity, and friendliness. This is Margit. I met Margit back in 1995 when she hired me as an intern to help with management of TNC preserves in Western North Carolina. That was a long time ago, but from that moment forward, Margit has been a constant in my career, offering mentoring, advice, and a lot of good quality critical review. But that wasn't the beginning. Margit was many, many years into a tremendous career by then. From founding both the Appalachians Fire Learning Network and becoming the first president of the North Carolina Prescribed Fire Council, to pushing boundaries of what we know about burning in mountain bogs, peat-based Pocosin ecosystems, and Appalachian mountain forest, Margit has always been a pioneer and leader in applied fire science. Way back in 1996, Margit partnered with the Rocky Mountain Research Station to determine ignition thresholds of ignition of vegetation in organic soils in the green swamp of North Carolina. That work resulted in a tremendous increase in the use of prescribed fire to manage those longleaf pine islands surrounded by these peat-based systems. And those places are absolutely full of biodiversity. The work that she did there was groundbreaking. It was nerve-wracking. They were lighting organic soils that might burn for months on end. Margit was pushing that because she knew that fire in those systems was going to be important to saving the biodiversity that existed there. And again, that work continues to this day. Her research and her work back then really carries the weight of how those longleaf pine islands are burned now. And you'll see all sorts of things from Venus flytraps and all sorts of crazy biodiversity in there. That's the work that Margit did. More recently, Margit was critical to the development of land fire state transition models for fire-mediated forests in the Southern Blue Ridge. That work has led to prioritization models, among other things, that help us make good decisions about where to burn, when, and how. These two examples are accomplishments through the Fire Learning Network and the Prescribed Fire Council. Those cannot be overstated. Margit and her colleagues made it happen. And those two institutions continue to provide leadership and learning, not just in North Carolina, but significantly beyond. Margit has led the North Carolina Nature Conservancy fire program for over 30 years, which includes the development of dozens of staff over the years, conducting thousands of burns. Margit was one of the first female fire managers in the Nature Conservancy and went on to help develop standards, training, and staff development programs that have helped hundreds of fire professionals along the way, myself included. Always willing to step up and help others, Margit has always volunteered her time to assist other state programs and agencies to participate in programs aimed at building capacity and reducing barriers for good fire management. She's always been a trusted and reliable partner. Her persistence, commitment to excellence and safety in what we all know is a challenging work environment has gained her credibility and respect which if you could read all the letters that were generated in support of this award, you would see just how valuable Margit has been throughout her career. Here's a couple of themes that I sort of went through all those letters. It was pretty awesome that we received from her peers and friends. Passionate, kind, persistent, advocate, mentor, spirit of going above and beyond, curious, determined, and open to learning. Please join me in thanking Margit for her tireless commitment to nature and people and her lifetime of accomplishments in the field of good fire management. Margit, congratulations on this well-deserved award. We're very thankful for you.
Well, Sam, thank you so much. I'm deeply humbled and I'm following your suit. I have no idea how to turn on my video. Can I get some help? Hey, we were joking earlier that, you know, I would follow up and messing things up. So
I just prompted you to turn on your video. You should see a button pop up that says, yep, you figured it out. Great.
all right, I'm here. Well, thank you again. I'm deeply humbled and honored to receive the award from AFE. It's an organization that I admire, and as ecologist and fire manager, AFE has always felt my professional home. So, and the Fire Congress has always been something to look forward to. It's an opportunity to learn, make connections, and deepen professional relationships. I currently live in Durham, North Carolina, on land once stewarded by the Tuscarora to support oak and pines and hickory forests and savannas. Sam mentioned, throughout my career, I've enjoyed burning, teaching, working with partners, and I would like to acknowledge a few events and at least some of the terrific folks I've worked with. My first awareness that fire plays an important role for biodiversity goes back to a fire ecology class by Dr. Norm Christensen, also another Stoddard Award winner. And I'm not in his league, not worthy. But this was shortly after I arrived in the US from Germany on what I thought was a one-year graduate exchange program. Field trips to the Green Swamp in North Carolina gave me a chance to see what fire can do to maintain one of the most diverse longleaf pine savanna. That's something that has driven, you know, some of the passion that Sam mentioned. And that was also the place where I started my experience with fire. Then in fall 1990, when a wildfire ignited organic soils that burned for weeks in the Green Swamp, I developed a partnership with Gary Curcio with North Carolina Forest Service, who had connected with the Fire Lab in Missoula. So I learned so much from working with Roger Hungerford, Jim Reardon, Scott Bergen, and of course, Gary, that I was really delighted to take the opportunity to shift from managing preserves statewide to just focus on fire. Sam also mentioned land fire. So here, Jim Smith was a key player in my thinking. He bravely presented me and local partners with national and regional maps that, let's say, in the beginning, were just not quite spot on, actually pretty far off. But Jim challenged us to improve the land fire products, not just complain. In exchange, he provided resources that allowed us to develop local landscape maps and models. So we worked with Cecil Frost, another award winner, and Jen Costanza to come up with pre-settlement vegetation maps. We worked with Steve Simone in the mountains to develop an ecozone map model for the Southern Blue Ridge, which became foundational for forest planning and deciding where we work. We also worked on revising land fire stage transition models. And I admit that was at times a painful exercise for managers, but it structured our thinking, how natural disturbance processes, including fire, worked, and it shaped our vegetation and management approach across North Carolina and beyond. So thank you for the challenges, Jim. Then of course, Sam and also Judy Dunscombe, who works with Sam in Virginia, hold a special place in my heart. As Sam mentioned, they started as interns with TNC in North Carolina before moving to Virginia. And they partnered with Charles Lafon and US Forest Service in foundational fire research in the mountains. That led to the establishment of the Central and the Southern Blue Ridge Fire Learning Network. For many years, Sam also has been my backup fire manager on call when I went on vacation. Thank you, Sam.
You're welcome.
You've been a fantastic partner and leader. We also share Beth Buchanan as a resource. She's a regional ecologist with the US Forest Service. Aside from sharing her expertise, she's been tireless networker, teacher, cheerleader for our work since 2006 and has been connecting the 3 Southern region fire learning networks. She keeps us closely connected to the cohesive strategy team and US Forest Service. Thank you, Beth. Tom Waldrop, Helen Moore, Steve Norman, Don Hagen, Adam Coates, Peter Bates, all have really shared their time, knowledge, and research insights with the Southern Blue Ridge Fire Learning community since 2007. They've all stayed engaged with managers, not just at the workshops, but throughout the year. And Tom and Helen's leadership role with the Consortium of Appalachian Fire Managers and Scientists, or CAFMs, has been absolutely outstanding and key success for the Appalachian FLNs. Thank you all. I could say the same for Joy Royce, Jim Fassett, and Laurel Keys, David Godwin, and all the other folks with the Southern Fire Exchange. You all have done the same for us in Longleaf. Thank you. I want to give a shout out to Bill Jackson and Melanie Petrolo, who made PC-based high split available to managers. This may be primitive by Kevin's standards, but it helps us to increase our burning and manage our smoke better. They've also patiently trained us in the use of the PC high split. And then Gary again and Cape Sperry incorporated modeling into North Carolina smoke management plan, which greatly increased our burning opportunities. I've been so privileged to work with so many federal and state fire managers across the state, and way too many to read all the names. I acknowledge that working across agencies, each with its own mission and constraints, is challenging at times. I learned, however, the rewards go well beyond access to perhaps limiting resources to expanding our horizons and at times challenging our working assumptions in doing so. I would be remiss not to mention my TNC fire leaders, Ron Myers, Paula Seaman, Blaine Hoyman. Each one of them has been a great mentor in using science-based fire management, managing risk, hosting collaborative training workshops, planning and implementing fire. Thank you all. To FLN, Angelisky, Doug Ladd, Lynn Decker, Wendy Folks, Merrick Smith, and Emily Holman have been outstanding leaders and resources to me and my partners in the Fire Learning Network. Liz Rank's networker connects us and keeps us together across the country. Thank you. My NC Fire team, Angie Carl, Mike Norris, Adam Warwick, Camilla Sterrett, all incredible practitioners, instructors, mentors, and leaders. They manage TNC seasonal fire crews, which are shared with partners to address landscape level fire needs in North Carolina. We miss Angie and Mike, who moved on recently. This team has worked hard and smart, carrying the core of the North Carolina fires work on the ground for years. Thank you. US AFE community have supported me with kindness and donations. When my husband had an accident at the start of the last fire congress and then passed on later that week. Your support as community meant a lot. All of you, especially Wendy Folks, Chip and Yvonne Babb, Cecil Frost, and Tom Waldrop, and Annie Oxerar. Thank you. I also want to quickly acknowledge my family in Germany, who supported their only daughter to follow her dreams and heart, even if that led me far away. My mom named me after Margit, an opera singer she admired. Sadly, I've never been able to carry a tune. My high heel shoes are my fire boots, so clearly I fell far off her expectations. Nonetheless, she would have been very proud knowing of my award, and I know my dad is. We have an incredibly talented fire teams that collaborate across boundaries and agencies in North Carolina and the southeastern US. Sometimes things will not go as planned. In those moments, think of John Blanchard, who once said, "Never let a good crisis go to waste. Learn from it to change for the better." So with that, I'd like to keep the flame going so I can keep seeing your smoke rising, well dispersed, of course. Thank you.
Thank you, Margit.
Thank you so much. And I'm going to actually invite Morgan to the virtual stage so he can close us out. We need to unfortunately end this session so the next one can start, but we look forward to presenting the next award at our plenary on Friday.
Thank you. Kevin said that that's this is my favorite part, and I sent him an ugly crying image of me that he agreed was very ugly. I love the Lifetime Achievement Awards the best. I'm a Lifetime Achievement Awards sucker, and I'm also a crier. So I wish I wasn't on video right now. Margit, that was wonderful. So we have a few minutes before you'll start your next sessions, which are on the hour. And I wanted to just say a couple things about those. One was the session that'll be in Spanish and Portuguese this afternoon is the Actions for Sustaining Biodiversity in Fire-Prone Ecosystems with Luke Kelly. And this evening, there's another opportunity to join in great networking with the Student Association for Fire Ecology, or SAFE. They're holding a career panel and discussion beginning at 5. And again, in Whova, agenda tab, and down to sessions. Lastly, I wanted to remind everyone about the poster session that's tomorrow from 3 to 4 Eastern time. It's not only a tour, and I know that like me, I think you've probably gone and taken a look at a few, but the poster presenters will be there to interact. And as that last exchange with Kevin, Sam, and Margit, this is the stuff we miss the most. So I hope that you can engage in that. Otherwise, you've got a few minute break, and we'll see you back at the hour. Thank you so much. Thanks, Margit.